Grant's original design for the SuperBoard upped the video to 64 columns by 32 rows. In a previous video, we got the display to run on a VGA instead of the composite, which what originally was designed for. The limitation of this was that it produced a small picture within the larger screen. Let's take a look at what it'll take to stretch the video on the UK101 display. VGA timing is shown here in the timing diagram, and it's basically 800 pixels horizontally with a clock frequency of 25.175 megahertz, which would be a bit rate of almost about 40 nanoseconds. Of that time, 640 pixels are displayed, and this time up here, 800 pixels is the total time per line. So another way to work that, you can see the horizontal frequency for that up here is 31.4 hertz, or excuse me, kilohertz. Here's the horizontal clock shown on the oscilloscope, and it displays as 31.25 kilohertz, which is very close to the calculated value. If we do this transformation right, we should still have the same horizontal rate. You can see the horizontal time for that would be 31.469 kilohertz, which should work out, if we do the math here of the clock rate divided by the 800 pixels, should be the same number, is 31.4 kilohertz, or 0.031 megahertz. So if we multiply this times 1,000, we'll get the rate in kilohertz, horizontal rate. So how does that compare to the SuperBoard? Let's take a look at the SuperBoard resolution. The SuperBoard II resolution, pixels that are displayed, it's 64 characters, and those are 8 pixels wide. So that's 512 clocks, and that's why the display doesn't fill the whole screen. It's only 512 out of the 640 wide. So if we wanted to make the screen fit horizontally, then we would multiply times some factor, and the factor would be 512 divided by 640, or 8/10. So if we change the clock frequency from, and these are actually doubled because it's running at 50 megahertz for this particular setup, but if we tried to do that same factor to the clock, we should be able to determine a clock and set the PLL inside of the FPGA to generate a slower clock rate, which should lengthen the line out. That would be a rate of 50 times the 0.8, which is around 40 megahertz. That's a good rough start for calculating the correct number. But notice here that VGA uses a 25.175 megahertz clock, and the clock that's on the FPGA that's being used is a 50. So it's not exactly a power of 2, so this 40 number is actually a little bit off. So how do we get a clock that's about 40 megahertz out of a 50 megahertz clock? If we have a counter, the best we can do is divide by 2. Well, fortunately, the Altera parts have a phase lock loop inside of them that can generate almost any frequency you'd ever want to generate, but let's go see what it takes to set that up. The clock that we need to generate is actually a little bit faster due to the upshift here, 25 versus the 25, half the 50 we normally use. So that would scale it up to 40.28. We want to make a clock of 40.28 megahertz to run the video part of the SuperBoard TV module, that as it's called, and that should give us video that fits horizontally across the screen. Let's take a look at what we have to do that inside of Quartus. I'm running Quartus 18.1, the light edition, Quartus Prime. To create a PLL module, go into the IP catalog, basic functions, clocks, PLLs, and resets, and then PLL, and then select Alt PLL. If you double click on that, in my case I like to make a VHDL file, and let's call this video CLK2. Call it anything you want, but that's what we're going to call it. I've already gone ahead and created, but I'm running through the process again of creating it here. You click that, the Mega Wizard plugin manager opens up, and I select the speed grade 7 part. We have to enter the frequency of our oscillator on the card, which is 50 megahertz, and I just leave all the other defaults. Seems to work just fine. I don't think it's necessary to create a locked output, but I left it on when I created mine, and I just ignored the pin. It didn't have any effect that I could tell. I don't think there's any need to do anything different here for spread spectrum or bandwidth. No need to create an input clock for a second clock. No need to do anything else here that I can figure out. And that will let us now go to the screen that lets us set the frequency. So click the button for enter output frequency, and we were looking for 40.28 megahertz. 28 megahertz, and that says that the part with the divisors and multipliers, multiplying by 29, that 50 megahertz times 29, and dividing it by 36, which is as close as it could get with integers, that it would give an output frequency of 40.277. Well, 3 parts in 4,000 is less than 0.01%, so that's definitely good enough for any monitor you find, I would think. And these are the parameters that it'll use when it creates the PLL. For the rest of it, I just click through. There's no Core 1 output, there's no Clock 2 output, there's no Clock 3 output, no Clock 4 output, and that should be fine. And then click it to finish it and create the VHDL component declaration file. And what it asks, whether you want to put it in all projects, well, that's up to you. I'm just going to put it in this particular project. All right, let's go take a look at what it created. It created a quip file, which doesn't really have anything useful for what we care about, but the VHDL file looks like this. And the entity that it created has a reset. Note here that it's active high, and our reset in our card is active low. Has the in clock, which we will hook up to the 50 megahertz clock, and it has a clock out, which will become our video clock. I'm going to switch back to the one that I already created, but the changes we have to make are really pretty simple. They're done here inside of the microprocessor module itself, and they really consist of not a whole lot of stuff. Basically, you have to create a component for that, and I put that component somewhere in here, right here. Maps the ports. Remember, the clock was, or the reset was not reset, so not the end reset that the chip is set up with. The in clock is just set to the clock, which is the 50 megahertz, and C0, which is CO, I guess, is video clock signal. So the change inside of the UK101 text display module is to use that new video clock as the clock, and that means that video clock has to be defined up here in our signals list as a standard logic. Once you do that, it should just work. Let's take a look and see what it looks like. After the change, the horizontal frequency hasn't changed. We also had to tweak some of the parameters for the line count to get the syncs correct and the video active correct. And here's what the monitor looks like after the change. As you can see, the video is stretched from side to side of the screen. It's not stretched vertically because that's a line count issue. To solve that, probably the only way to do that, it would be to make or get a font that's a taller font, maybe a 8 by 12 sort of a font. But this particular setting gets all 64 columns and they're spread across the screen. And it's certainly very readable and usable. So I think I'll stick with this as the answer to the problem, and maybe later look into getting another font. But hopefully if you want to try this on yours, I'll put the code up in the GitHub and drop a link down in the bottom for it. Thanks for watching. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.